Section 7.4 is titled Equations in Quadratic Form. So you have to know what that means. What does it mean to be an equation in quadratic form? Well, a quadratic equation would be an equation in quadratic form, but this is more general. So we want to know how to solve these things. And so first we have to know what the heck it is. So definition, an equation in quadratic form is an equation that can be written in this form: AU squared plus BU plus C equals 0, where A, B, and C are constants, with A not equal to 0, and U is some algebraic expression. So before, we just had an X there instead of U. So that's not very complicated, right? We just switched the X and the U. But the U is actually not initially written as a U. It's usually something else. U could be X squared. U could be X minus 2. U could be the square root of X. U could be log of X or something. It could be anything, okay? It could be a trig function, but not in this class. Okay, so that's an equation in quadratic form. It can be written that way, this way, that way over there, right? So just a definition. So here's an example, a very common example actually, probably the most common example. U is X squared. Okay, so initially this would look like this. So when you see ax to the fourth plus bx squared plus c, that is an equation in quadratic form. It's a fourth degree polynomial, which we call a quadratic, but it's not a quadratic, right? A quadratic's a second degree one, but I can write it as a quadratic by substituting u equals x squared, right? So that's actually x squared squared. Notice the middle term, the variable part of the middle term tells you what u is. What u is, right? U is x squared. Here's another, now I'm just giving you basic examples. Then I'll run through examples with actual numbers and everything for A, B, and C. But first, this is just different types, different things that could happen. You could have U be x to the 2/3. Then what's it going to look like? Ax to the 4/3 plus bx to the 2/3 plus c. Notice what the pattern here is. You have three terms, trinomial. You have a constant term at the end. You have a middle term, and then the variable part of the leading term, the highest power, is the middle term squared. In other words, if you take the exponent and multiply it by 2, you get the exponent of the first one. So you have to recognize this when you see it so that you know it's an equation in quadratic form. And you have to recognize it no matter what the variable part of the middle term is. But the fact that it's something weird that you haven't seen a lot before, and it's a trinomial, is kind of a giveaway, right? Again, if you did have a common factor between all three terms, you would factor that out first, but we don't here. Well, unless A, B, and C have a common factor. Here's another example. U is x minus 2 to the minus 1 power. So what's that going to look like? Looks like that. See, the first term there is just the square, the variable part, well, the part other than a, is the square of the middle term other than b. See, if you square the quantity x minus 2 to the minus 1, you're multiplying the exponent by 2, which gives you exponent negative 2. Now, technically, the leading term on this is actually the c, because that's the highest power of x, because they're negative powers. but we still write it this way. Don't let it mess you up. Okay, so let's do some specific examples.